Okay, so in this lesson, we're going to learn how to solve a system of equations graphically. All right, so graphing is one of several different ways we're going to learn how to solve a system of equations. In the first lesson on systems of equations, we just checked if points were solutions or not, so we didn't actually solve them. Okay, well, let's get started. So the solution to a system of equations is where two lines intersect. Okay, so what we're going to have is on a coordinate plane, we're going to have two lines that are going to meet somewhere, all right? And there's three possible cases. This is the most common case, all right? So we've got these two lines that meet at this point. Let's say this is the point 4, 2. Okay, so this would mean x is 4 and y is 2, right? Because they meet at the point 4, 2. Obviously, the x comes first in a pair of coordinates. Okay, so the solution to the system is x is 4, y is 2, and this is your scenario where you have one solution. You have two lines that intersect or meet at one point. Okay, the second possible outcome is going to look something like this. Okay, we have one line, and we have another line. Okay, and remember, we're looking for the lines intersect. Do these lines intersect? No, they are parallel. Okay, parallel lines by definition don't intersect, so this is your scenario where you have no solution because no intersection point. All right, that's your second case. Third case, we have one line, and then if I have another line that's right on top of the first line. Okay, so again, this is really two lines. It looks like just one. So these lines are intersecting everywhere. They're right on top of each other. Okay, remember the lines go on forever, so they're intersecting at infinitely many points, intersecting here, 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 there, there. Okay, these are parallel lines. These are called coinciding lines. All right, coinciding lines are just two lines that are right on top of each other. Okay, so you three different possibilities. We have one solution, which is intersecting lines, no solution, parallel lines, and infinitely many solutions, which are coinciding lines. All right, let's take a look at a question. So we want to graph this system and write its solution. We can also answer no solution or infinitely many solutions. All right, so you should notice the bottom one's in slope-intercept form, top one is not, so we want to change it to slope-intercept form. Of course, I'm going to add 2x to both sides. Okay, that's going to give us y equals 2x plus 6. Okay, so we're going to graph the top one. This is a y-intercept of 6, slope of 2 over 1. Okay, so we're going to go up 2, 1 right, 1 over, all right? And then with a ruler, you want to do this very carefully or else you're potentially going to miss the intersection point if there is one. All right, I'm going to take a ruler and carefully draw the line through the 2 points. Okay. All right. Now the bottom equation is already in slope-intercept form. It has an intercept of -1, slope of 1 over 4. So we're going to go 1 up, 1, 2, 3, 4 over. All right. Again, using a ruler. Make sure I get the points lined up nicely. Okay, there's my second line, and where do they intersect? They do intersect. They intersect right over here at -3 -2. Okay, the coordinates of that intersection point right here where the two lines meet are -3, -2. So your answer would be, since they intersect, x equals -3 and y equals -2. All right, let's go to the back. Okay, so in this one, the top one's in slope-intercept form, the bottom one is not, so we're going to add 3x to both sides. Okay, so we have y equals 3x minus 6. Okay, so the top one, intercept is -1. Slope is a half, so 1 up, 2 over. Okay, that's our first line. Second one, intercept is -6. Slope is 3 over 1. 2, 3. Okay, which can go right there. All right, so these lines do intersect. Where do they intersect? They intersect at that point right there. The coordinates of that point are 2, 0. Yeah, fix that too. All right, so since they intersect, that means the solution is x is 2 and y is 0. All right, last one. So top one is not in slope-intercept form. We're going to subtract 2x to both sides. So we have y equals -2x minus 4, and then y equals -2x. We can add in a +0 there since that's one's missing an intercept. Okay, so the top one, intercept is -4, and then we're going to go down 2, 1, 2, and over 1. Oops, messed up a little bit down here. Sorry, it's not easy to hold a ruler and my phone at the same time. Okay, the bottom equation, intercept is 0, 2 down, 1 over. And when we connect, we have parallel lines, okay? Since they don't intersect, parallel lines, our answer is no solution. Okay.